Thanks very much, Alexander. Hey, so welcome to my talk, GraphQL Federation using the Neo4j GraphQL Library. I've already had a bit of an intro, but my name is Darrell. I'm a senior software engineer at Neo4j. I've been working in the GraphQL team since January 2021. You can follow me on Twitter. I'm not madly active, or you can email me, darrell.warde@neo4j.com. It's great to be speaking at Nodes again. I remember fondly speaking last year. The London office wasn't even open yet post-COVID, and a few of us went in and did our talks from there. It's a fond memory from my kind of early days at Neo4j, so it's great to be speaking again. So if you've seen one of our team's talks before, we'll always start with a bit of a basic run through of what GraphQL is. Then we'll dive into kind of what Neo4j GraphQL is before going into any specifics that we're going into in this particular talk. So starting with GraphQL. GraphQL is both a language and a runtime, and it allows you to describe your data. So you can see here on the left, we've defined this type project that has 3 fields: name, tagline, and contributors. All 3 of those fields are strongly typed. The name and tagline are a string, and contributors is pointing to another type in your GraphQL type definitions. Once that's loaded into a schema and it has the underlying resolvers, you can then ask for what you want. So you can basically say, hey, I want a project which has the name GraphQL, and I only want the tagline for that project. It's extremely declarative, and you get what you ask for and only what you ask for. And then in your results, everything is predictable. So it's in a JSON structure where you have a project and then tagline, which exactly matches your query. And you can see here that the tagline is a query language for APIs. GraphQL is, under the hood, kind of all run by type definitions and resolvers. We'll start at type definitions. You can see here that we've defined 2 types. Type movie, very similar to the project before. It's very simple. It has a title and a runtime. One is a string, one is an integer. Then there is a very important type. You can see this is type query. This is one of the root kind of types that the query type must be in every GraphQL schema. There's 2 others called mutation and subscription, which are optional. Mutation is for writing things, and subscriptions, if you saw our talk at Graph Connect, is for real-time data queries to a GraphQL schema. So you can see here we're defining a root level query called movie, which allows you to pass in a title, which is a string, and you'll get a movie back. But type definitions can be even more powerful. You can also link between types, as I said before. So you can see here that acted in this actor type is a type movie, which is another type defined in the type definitions. But then you can also see on the name of that actor that we've added this deprecated directive. Directives are a powerful way of adding in additional functionality into a GraphQL schema or query. Deprecated is one of the built-in directives into the GraphQL language. And this just allows you to kind of say, hey, in the next major release of this API, we're going to be getting rid of this field. And this is the reason why and what you can use instead. And directives are one of the ways that the GraphQL library at Neo4j is quite powerful. And resolvers go with type definitions. They're like an exact match in terms of the maps. So you can see here we have a query, and there's that movie field, which we defined in our type definitions. So you define your resolvers in the same way, in the same shape that you define your type definitions. And you can kind of get the arguments from that query, and you can then do something in some JavaScript function to fetch out data and return it to users. And then there's a query language. The query language is split up into multiple parts. So query, mutation, and subscription are the 3 operations I talked about. You can give a particular query an optional name. So we've called this query find movie. Then you go into the field which you're querying. You pass in some arguments. So we're looking for the terminator here. And then this is known as your selection set. And here we're asking for the title and runtime of the movie matching that filter. So GraphQL Basics over. What is Neo4j GraphQL? And credit to Andres and the team for this incredible gift. It fills me with great joy. So GraphQL for Neo4j. It sits in the middle of a Neo4j database and a GraphQL client. And it's a JavaScript library that allows you to write some very simple type definitions, pass them into the library, and we'll do just a bunch of automatic generation of type definitions and resolvers to allow you to execute GraphQL queries and they will get automatically translated into Cypher to a Neo4j database and returned in the JSON structure that a GraphQL client requires. So one of the kind of downsides of GraphQL as a whole is the amount of boilerplate needed. Whilst you can see here a really simple type, movies are our concern and we only care about the title. But then if you think about if you were defining everything you needed yourself, you'd be defining at least one query. You can see here we've defined one query to get a movie, and then potentially 3 or more mutations if you want to be able to create a movie, remove a movie, or update a movie. This is fine. It can just be very time consuming, and don't forget that you've got to write all of these resolvers under the hood as well when using GraphQL. So we think there's a better way. We think type definition boilerplate is not the way forward here, and automatic schema generation is what we should be aiming for. So with those simple types, type movie, title, string, you will just get a bunch of automatic things generated. So 3 queries you'll get for that particular type, which allows you to query movies, will generate all of the options for sorting, pagination, filtering. You can get all of that back. That's all kind of generated for you. We'll do all of the Cypher translation for that. You can do aggregates. So if you want to do counts and sums and longer strings, shorter strings, a bunch of aggregation capabilities built in there. And then finally, something more specific, which is this movies connection. This is an implementation of the relay specification, which allows you to do cursor-based pagination across your data that you have stored in your Neo4j database using the GraphQL library. We'll generate a bunch of mutations, create movies, delete movies, update movies, all of the inputs generated for you. It will kind of deal with everything you need to kind of do basic CRUD operations of the data in your database. And the Cypher translation just hooks up perfectly into GraphQL. So you can see here that movie field translates into a match clause in Cypher. The arguments go perfectly into a filter where m.title is the terminator, and the selection set will only ever select exactly what you've asked for in GraphQL. Will never return the entire node. So it's about as performant as it can be in terms of the data that would bring it back from the database. So what's this federation thing that you're here to talk about? This is made by Apollo GraphQL. Apollo are kind of one of the leading companies in building GraphQL tooling for the GraphQL ecosystem. And the kind of basis of GraphQL Federation is that there's this concept of a graph router. And this router talks to a number of subgraphs. You can see here that this example in this diagram, credit to Apollo, has a user subgraph, a product subgraph, and a review subgraph. They are all stitched together using a graph router, and you can query that graph router as if it was a single GraphQL schema. And things can be related between the subgraphs, so you can run a single query which might run across all 3 subgraphs. The need for this arose, and I've been in a situation where there's a variety of teams. Back in the early days of GraphQL, they would have just all been working on a single GraphQL server, modifying the type definitions as they needed, modifying the resolvers as they needed, all kind of fighting for space within the same GraphQL server and the same GraphQL schema. This meant that things could break extremely easily. There was no clear owner of that GraphQL server. It was shared ownership with no one making the call on what should and shouldn't go in. And it was getting very messy. There was attempts in the early days. Schema stitching is one that comes to mind, which I still believe floats around, which was a bit more simple than GraphQL Federation, which kind of just stitched together multiple GraphQL schemas into one, but then at the end point, it was just a single GraphQL schema that was kind of being executed, and it was not as good as stitching together the different subgraphs as Federation is today. Fast forward to right now, and all of those teams now own their own subgraph. So the domain of ownership is a lot more clear here. The user's team owns the user's subgraph, etc., etc. They're now all stitched together using a router, as Apollo now call it, with their most modern implementation of this gateway. And conceptually, this could be owned by some kind of graph team, some governance team, maybe not even a single team, but just a group of kind of nominated people to do governance of that GraphQL schema. And they manage that router and what goes in and what doesn't go in. And each team can kind of operate independently, but there is at the end of it kind of a single GraphQL schema which can be queried by anyone who needs the data. So what about composite databases, you may ask, or if you're still using version 4 of Neo4j, you might know this as Fabric instead. So we quite regularly in the GraphQL team get asked a question like, hey, my customer has 2 databases, so products and reviews. They're using a composite database or Fabric, and they're kind of stitching together all of the data in these 2 databases to be able to query them in Cypher. How can I add a GraphQL schema to that composite database, they ask. Now, this is quite tricky, and you'll see why when I do a demo in a short while. So we've been thinking for a long time, and we believe there might be a solution here which is slightly different to what is being asked for. And that is to put a GraphQL API on each database using the Neo4j GraphQL Library, generating all of the type definitions and resolvers for the data in those databases, and then stitch together those 2 GraphQL APIs using an Apollo Federation gateway or router. And we hope then that all users will be happy. We have the GraphQL API users who are writing web clients using the Federation gateway, but then also Composite is kind of still available. You know, nothing changes here. And those users who want to use that composite database are still able to do so. And we think everybody should be able to profit off a situation like this. So let's see it in action. But first, a small disclaimer. What you're about to see is the result of some serious CDD or conference-driven development. It's been a very hectic time building this with several kind of trip-ups along the way. So nothing is released yet, and it's still under active development. So things are definitely going to change from what you see now, and we're still figuring out what is possible and what isn't. So let me do some window switching here. So in Neo4j desktop, I have just a completely empty database here. I have APOC installed as is required by the GraphQL library. And we're going to go into Neo4j browser, bring that down onto this screen. I might zoom in 1 click just to make that a bit more visible. So let's kind of create this products and reviews situation that was in the diagram before. So we might create a database, products. I can never spell products right under pressure, so this is a good test. We're going to create a database, reviews. We're going to create a composite database. Let's call it store, which is a store selling products, and some of those products have reviews. And then now with composite databases nowadays, you can configure how that composite database works all in Cypher, which is super nice. So we might say, for instance, I want to create an alias called store.products for database products. And then I might create another alias called store.reviews for database reviews. So right now we have 3 databases created. We have our products, our reviews, and our store, the store being a composite database of the products and reviews database. So now let's just add some data in. So let's use products first. Let's dump in some products. I have some Cypher that I wrote earlier, which I'm going to use for this situation. This is a fruit shop. They're selling fruit. This is great. So let's dump just 5 fruits in here. And then using reviews, let's create some reviews. But first of all, let's kind of, I think, putting a stub of your products into this reviews database is going to be essential here. So we're going to create just the fruits which we created in the products database, but we're just going to give them the same IDs. So this ID is like the key between both databases. And then what we're going to do is just create a bunch of reviews for all of this fruit, which is going to be a review node linked to the fruits or the products by has review relationships. So let's create all of them. This has created 15 labels, 15 nodes, as we would expect. So now let's jump into our store database. Because of time, I think I'm going to kind of be a little bit cautious on kind of how much I type and how much I copy paste. So I will kind of copy paste on this in. So when you're querying a composite database, you need to kind of use the use command to kind of say, hey, I want to query this data from this database and this data from this database, and then stitch it all together. So let's just say we want to do products to start with. So you want to match products from the product database and return the fields of that product. And then using union, I want to join together the products also from the reviews database. So, but this time I want to also get the reviews as well. So if I execute this, this should work very well. But you can see there's a slight problem here in that we've actually got duplicates of the data here. So ID 3 of the fruit there, we've actually already got this up here. So that's not a great way of doing it. So what we need to do is kind of some jiggery pokery to kind of get the products. So matching P product, we want to return the fields as product, and then the ID is product ID. And then what we can do is using that product ID, we can go into the reviews database, match the products that match that ID, and then get their reviews. And then at the end of it, what we can do is we can merge our products and our reviewed products together as products using apoc.map.merge. So it's not trivial. And I think I wanted to demonstrate this because it's not easy to do this in the GraphQL library. To kind of, not only are we saying that there is the data in one database and the data in another database, but we need to generate all the type definitions and resolvers for. Being able to kind of say, oh, how does this data join together in the Cypher? It is going to be an extremely difficult task, and we should try to lean on our auto generation, which we have at the moment, as much as possible. But executing this, you can see here, this is much nicer. We have the products as we need them, with the reviews as an array on each one, and there's no duplicates in this. So this is super nice, but let's jump into Federation. So I have here a couple of example subgraphs as they're known. This is just an example application, literally on the development branch where I'm working on this Federation stuff. And we've defined these type definitions here. You can see that something which you may or may not have seen if you've used Apollo Federation is this extend schema with the link directive, which basically imports the type definitions from the Federation specification. And then we're saying we want to import the key directive. And then we define, this is our products database, so we're defining our product type with 3 fields. And what we're saying is the key for this product type is ID, it's the ID field. Then what we're doing is we're doing our usual things that we need to do for the GraphQL library, so constructing some kind of driver. But then there's something new here. So there's this plugin, Neo4j GraphQL Apollo Federation plugin. Now, this is very much part of that CDD and getting something working. We hope that 0 of these arguments will be needed in the future, and you can literally just construct an empty plugin like with 0 constructor arguments. But this is the way we are now. What we then do is we construct an instance of the library. We are having to skip the validation of type definitions for now, once again, because of just kind of time restrictions of this conference. In the end, you will not have to do this. And what we're doing is we're passing in a driver config saying we want to use the products database for this particular library instance. We then want to pass in the plugins, and we're passing it into the Federation slot. We're thinking of maybe a generic plugin slot for this in future. And then what we're going to do is we're going to get the schema definition from the library. So this is actually returning the type definitions and the resolvers rather than the schema itself. And then we're going to pass that schema definition into build subgraph schema. Once again, we hope for this you'll be able to just use the Apollo's build subgraph schema from the Apollo subgraph library. But for some technical reasons, we've had to put a wrapper inside the plugin for now. But the result of that is you get a schema, which is a subgraph schema, which can be used to be stitched together using a federation gateway. We then just create a simple Apollo server, we start that standalone server, and away we go. So we have something similar here for reviews, that same extension. This time you can see we just defined that stub product type, and then we've defined our reviews, which have 3 fields: score, description, and then product, which is using the relationship directive from the GraphQL library to go to the products. And then it's exactly the same boilerplate as before, but just pointing to a different database and starting on a different port. So what we can do is we can kick them off. So I'm just using TS node just to execute the TypeScript files to start these servers. That's going to start at the products one. And then I'm going to do the same to start the review subgraph. Products is running on port 4001. Reviews is about to be running on port 4002 when it decides to sort itself out. Wonderful. And what we can do is we can, apparently something is going a bit weird here. Thank you. Cool. So on port 4001, we can see that this is, if you're familiar with the GraphQL library, exactly what you'd normally expect to see. Zoom in a few clicks. You've got all of your generated queries and mutations, but there's some new stuff in here. This has come from that subgraph generation, and also some new kind of enums. And at the top, we've got all of these directives, which are for the federation purposes. However, you can see if we look at some of these types that they look fairly normal. However, if you go into the schema diff, you can see that for federation purposes, we've also added in this kind of federation shareable across the place, which allows this schema to be stitched together with other subgraphs generated using the plugin. This one also has exactly the same. This is still, a perfectly normal schema. You can still query your products in this, and it still works just fine. But then jumping back into VS Code, the cool thing is this whole supergraph thing is quite hands-off. You need to just download what's known as the router, which is using a curl command. You download it from the Apollo website, execute that. That's going to do its thing. There we go, and it's just saved to the current directory you're working in. And then there is a command called rover, which can be used to compose. I will delete that just to kind of show that this is actually working as it does. And what you do is you rover supergraph compose, and you're composing it using this supergraph configuration, which says kind of what version of federation we're using and then where the subgraphs are located. So there's locations on 4001 and reviews on 4002. And then you output the output into a GraphQL file. And then you can see that basically it's joined the two together. With instructions on how to get between the two subgraphs somewhere within this supergraph. And then finally, we run the router using that supergraph file. And that's now ready to be used on port 4000. And we can jump into it here, and it's here like this. So we can do queries such as getting the products and their IDs, their name and price, but that's not really using federation as we want to. What we can do is instead, you notice that I put that relationship directive in the reviews type. What we can do is we can jump down that relationship and we can get the name and the price. So notice here that in the reviews, description and score were fields in the review type of the review subgraph. However, only ID existed in that subgraph, but this is allowing us to also query the name and the price. So this single GraphQL query is essentially going to result in multiple queries across the different subgraphs in a really transparent manner to users, which allows you to then execute this query and get all of the data back in that same predictable manner that you've been used to having when using GraphQL. I'm not going to demonstrate any more than that today because I fear that it will break. It's still, as I said, very much in development. We will get a kind of an early access for this out as soon as possible. But far off a stable release for now, but we'll do kind of betas and alphas or whatever, just any way to kind of get it out to users ASAP, really. Cool. So back to slides. I've got 10 minutes and we can kind of accept questions in Discord anytime. So really, I want to spend 10 minutes just going super fast paced. What else has the team been up to? Because we've been up to some really cool stuff. At Graph Connect, we talked about subscriptions. If you watched that talk, you may recognize this diagram. We just spent time going through the architecture which we're building for GraphQL Subscriptions, which allows you to horizontally scale the library so you can have multiple Neo4j GraphQL instances with multiple clients. But then with subscriptions, if a mutation comes from one client, but another client is subscribed, we need to be able to get those events between the two. So there's this whole architecture of that mutation results in a Cypher query. This results in an event that goes to some kind of broker, which then gets broadcast across all horizontally scaled instances, which means that any client can get any subscription event from any other client. Super cool. We've been working towards getting subscriptions stable for a while now. At Graph Connect, this was the state of the subscription type. We had movie created, movie deleted, movie updated. It was fine, but we felt like we're a graph database. We need something to do with relationships before we release a stable release of this. So we're working hard towards these new additional subscription fields, movie relationship created and movie relationship deleted, which will allow you to trigger off connection and disconnection events between nodes with kind of good kind of filtering compatibility to allow you to really start building graphy applications using GraphQL. We will likely do a stable release when this is done. Kind of timelines is probably late this year in a non-committal way. But then we are going to continue working on this beyond there and also do movie relationship updated. So when relationship properties are changed, being able to kind of get events based off that. So we really want to take this a long way and make this a great feature for users. We've also been focusing on speed. We've been having performance kind of in our mind for a long time. And a while ago, we figured it's finally time to dig into this. One key area we've been looking at is optimizing create operations using unwind. So for example, a create mutation like this, creating 5 movies, it would result in Cypher that looked like this, with a single call for each node being created. This would reach like 500 nodes and then it would just die flat on its face. It was not good at all. So fast forward to today, we're still working on this because it's not compatible with all features of the library yet. But we're moving towards Cypher that looks like this, where we're unwinding the movies to be created, and then just doing a single create across each of those elements which are being unwound, and then returning all of those movies. This is just such a great improvement, and we think it's pretty cool. But we have been working on a variety of other performance-related tasks. In one of the most recent releases, we kind of increased schema generation by about 50, or reduced the time by about 50%, hopefully. And then we've also been doing kind of a variety of optimizations to the Cypher we generate under the hood to make our queries much faster. And we're going to continue to look at this as time goes on. Now, a quote from the GraphQL team. Building Cypher queries is hard. And kind of here's some live footage of us in the office trying to like mash together Cypher into a way that works for what we need it in the GraphQL library. So we needed to do something about this. And this is where the Cypher Builder came along. This is a brand new library which has come out of the GraphQL team. And it's what we're using in the majority of our Cypher generation in the library now. So this is available, but this is a quick example of how you use it. You define parameters using cypher.param and you give the value to that param. You define nodes using cypher.node, defining like things like the labels that you want that node to have. And then you can do things like, new cypher.create, create that node, set that parameter, and then return the movie. And then you can then build that query. And then the output looks something a bit like this. We've automatically escaped the labels you can see. We've built the parameters out into a JSON object, which can be passed into Neo4j. And this will work to create a movie with an ID. We're still working on this. It's super early access, but it is available on NPM, Neo4j Cypher Builder, which can be installed using NPM, Yarn, or PNPM. Please use it, give us feedback, but keep in mind that it's about version 0.1.5. So we're probably going to still be making breaking changes to this as we go along. Finally, we've been investigating a managed GraphQL API service as an option for the GraphQL library. So that would be us hosting your GraphQL APIs in the cloud with Aura databases for a cloud-first solution for GraphQL and Neo4j. And we are at the moment running a survey, kind of looking for your feedback on the library and what you'd like to see in this kind of setup. So if you have a moment, please kind of scan this QR code, fill that survey out, or there's a bit.ly link which can be handed around afterwards. We'd love to get your feedback on this so we can just build a great product here. All of this stuff I talked about today is not possible without an amazing team of developers and also an amazing open source community in our GitHub repository and in Discord. So I just want to kind of shout out to the team, shout out to everybody who's worked on the library, participated in Discord, raised issues, raised pull requests. It's really kind of what makes this a great product to work on and make sure we can get these improvements day to day. So please come join us on Discord, send us an email with any feedback. We appreciate everything. And that's it from me. Here's some useful links, slides from today, our GitHub repository, our documentation, NPM links to the GraphQL library, to the Cypher Builder, and that feedback survey again. I'm happy to take one question, but very short a time, I do realize that. Thanks for listening.
Hi, Darrell. Thank you very much. That was very interesting, very cool. You heard him. If you have a question, type it in. Your chances now. Rick had one, and I'm not so sure because I missed a bit over there, so I'm not sure you covered this or not, but let's quickly go over this again. Rick wants to know, can you explain why you needed the stub nodes? Are they like join nodes between the different databases? This was during your demo earlier.
Yeah, this was kind of done for the purposes of federation in the sense of in GraphQL, we can't, let's say that review type had a reference to the product type. We can't really add that reference to the product type in the review type if we don't have something of a product in those type definitions, because otherwise the GraphQL runtime would just kind of cry out and say, I don't know what products are. So by putting in these stub types, it means that key defined in that key directive is consistent across all of the subgraphs. So that product ID kind of becomes a persistent thing across databases and across subgraphs, which allows federation to work. But we're always open to better ways of doing this if anyone has any ideas.
Cool, makes sense. I see no other question. I see some feedback here. Adam, Cypher Builder is like Knex for Cypher. Awesome. So I think that's I hope that's a praise. I'm not so 100% what Knex is, but
oh yeah, well yeah, that's definite praise. Knex was a big part of my childhood, so yeah, I think it's awesome too.
Sounds good. Yeah, with that, I think you mentioned it all. Community, a Discord forum, Discord server, the GraphQL team particularly is very active there. Send us some clapping emojis. So that's always nice for Darrell to appreciate the talk. Yeah, well, we can do one more. Otakar, what about namespace clashes between databases? Is that a problem?
Unsure what is meant by namespaces in this sense. I can kind of give something on that, which is kind of, it can be quite tricky with federation if there's different fields in each GraphQL type across different subgraphs, because it will basically take the common fields, and the Federation gate will pretty much like throw away any fields which aren't in everything. So that can be a tricky scenario. But if you could reach out on Discord or something like that, I'd love to kind of
type names.
If it's like the type names, it shouldn't, like, if there's differences in type names, they will just operate as different types on different nodes. So there shouldn't be any problems with, like, the whole intention of Federation is that type names should be reused across different subgraphs, and that's how everything is stitched together. But if you have any examples of where this might fall apart, I'd be very open to hearing it.
All right, cool. Thank you, Darrell. Yeah, and yeah, thank you for your presentation. Thank you for answering a couple of the questions. And yeah, see you around, Darrell. Thank you for being part of Nodes.
Thanks for having me.